In light of the upcoming final project, let's talk about how servers make money. Now, it must be possible for servers to make money since there are several different companies and organizations that exist around that concept. For example, Amazon Web Services, or Microsoft Azure, or HostMonster, GoDaddy. What about online services like Office 365 or social media like Facebook and Twitter? All of these companies make a ton of money based on their server infrastructure. So the question is, how can we leverage servers in the same or a similar way in order to make a data center profitable? Now, over the next several minutes, I want to discuss some of the different types of services that can be offered. But this is by no means an exhaustive exploration of what's possible in the server world. My goal is to get your creative juices flowing, to get you thinking about how servers can be useful and profitable, so that you can do some brainstorming on your own for the final project. In broad terms, we can boil down some of the profitable services into a few categories: virtual machine servers, file servers, web servers, application servers, cloud security, and game servers. Given those categories, take a moment to think through various companies that you're aware of that might make money in one or more of those categories. This will give you an idea of how popular or profitable those particular services can be. Realize that many of these services are not well known in the public sector, and so you may not actually know how many different companies or what companies make money hosting virtual machines, or which companies make money by hosting cloud services like proxy servers. So if you're curious, do a quick Google search and see if you can find a company or a set of companies that make money on one or more of these services. As a quick example of each, Amazon Web Services is a great example of a company that makes money by offering virtualization services. Their Amazon Web Services portal makes it very easy to spin up instances of just about any type of virtual machine with any type of hardware resources at its disposal. And while the cost may seem small compared to buying your own physical equipment, Amazon is making a ton of money by renting or leasing small parts of its architecture to those virtual machines billed by the minute or by the hour. When it comes to file servers, consider things like Dropbox, OneDrive, or Google Drive. How much are people willing to pay in order to put data in the cloud, either for the flexibility of having it accessible across multiple devices or the security of knowing that it's backed up across multiple servers or multiple hard drives? In a similar vein, think about web servers. There are hundreds of small companies dedicated to hosting websites. Some of them have very public faces like Squarespace or GoDaddy. Several of these services combine website authoring tools with website hosting services. They essentially rent storage space and network bandwidth for those websites and offer configurations for those web servers so that individuals, small businesses, and even enterprise can have professional-looking websites with minimum investment on their own part. Application servers is another area that might be a little bit gray or unknown to the general public. But as one example, consider a company called Right Networks. One of their primary products is virtualizing and hosting a QuickBooks application, which is a bookkeeping software meant for small businesses, nonprofits, and even enterprise. By hosting that application for their customers don't have to worry about the complicated network setup of a shared company file or the maintenance of the hardware system required to store that file. Instead, Right Networks takes over all of that infrastructure and provides a simple end-user experience for that particular application. They charge a monthly or annual fee that, in my opinion, is fairly substantial. Essentially, you could afford to buy a brand new server just for QuickBooks every 2 years rather than paying that monthly fee. When it comes to cloud security, one of the most generally known services is that of the VPN. And there are several companies that are being advertised right now offering VPN services. Some of them are free to use, but others have paid subscription or offer higher tiers of performance for an added fee. But this is really just the tip of the iceberg when it comes to cloud-based security devices and applications. Companies are moving firewalls, proxy servers, load balancers to 100% cloud-based solutions. For example, a company can route all of its local network traffic to a firewall that may be hosted somewhere else in the United States, and that firewall will filter all the traffic to and from that organization. This transfers a lot of the maintenance and the burden of configuration of that firewall off to another site or another company. It also allows the collection of resources because multiple companies can use that same firewall. As an example, several of the colleges in Dubuque considered for a time pooling resources in order to pay for a rather expensive firewall service. Each of the colleges individually couldn't afford to pay for that particular service because it was on the order of $10,000 to $20,000. But they realized that if they put it in a publicly accessible place and routed all of their campus traffic through that firewall, they could all share that service and share the cost of that particular firewall technology. Lastly, game servers. While there are many games that have free servers online or allow you to play the game for free online if you've purchased the game, there are also several different games that require or allow you to purchase an online game server to host multiplayer games. Minecraft is one prime example. So take a little bit of time and consider these different services and what other companies are making money. Now obviously we don't want to try and directly compete with some of the big players because it'll be very difficult to convince a customer to use our service instead of theirs. For example, if we wanted to compete with Amazon, realize that Amazon has a lot invested in their infrastructure and architecture already, which allows them to offer their services at a significantly lower price than we could right off the bat. However, if we can tweak that service or change our clientele to make it more specific or add features that Amazon Web Services may not have, it may make our product valuable enough to attract customers. Once you've figured out the services that will make your data center profitable, the next thing that you're going to have to think through is what is the hardware required in order to offer these services. Now, of course, if we had an unlimited budget, we could just pack our data center full with the highest end servers that we could possibly configure and make tons of money. But we don't have an infinite amount of money, so we need to be more specific about how we develop these servers for each of these different services. Now, in another video, I've already talked about the hardware considerations for a virtual machine server. So I'm going to skip that one. And let's talk about web servers. Consider for a moment what a web server is and how it functions and what hardware might be important to that web server in order to provide the best service. Pause the video and take a moment. What would you prioritize between CPU, RAM, storage, network access? What's the most important aspect of the hardware for a web server? So what was your answer? If it was storage, you're on the right track. Keep in mind that a web server is essentially a file server. Every time a request for a website comes in, that web server is going to have to read that request, gather the files required for a response, and then send that response out. That means that every single HTTP request is going to involve the hard drive in some capacity. Now, unless we have a significant amount of memory and software that can cache the most used website files in that system memory, our disks are going to need to be very low latency, very high throughput in order to serve that content. Specifically, consider the fact that most websites are made up of several small files, which means that our input-output operations per second factor of our storage is going to be one of the most important. Now, if you were thinking to yourself that networking would be the most important factor to a web server, I see where you're coming from, but realize that most of these files are going to be relatively small. And so even a 1 gigabit per second internet connection will be able to host multiple thousands of requests per second. And since most web servers have 2 or more 1 gigabit per second Ethernet adapters built in, it may not be something that we have to put extra money into. Now, depending on the amount of websites that we're hosting on a particular server or the type of content, or maybe we want to advertise higher speeds, we may put some money into some 10 gigabit or better networking cards. But the difficulty of the web server is really going to be in providing high performance, low latency storage so that responses to those HTTP requests can be as fast as possible. Broadening out the idea of a web server to a generic file server, take a moment and consider what's going to be the most important aspect of a file server. CPU, RAM, storage, or networking? Have you got your answer? You may once again be thinking storage. Much like the web server, a file server is still going to need lots of storage space as well as low latency, high speed access. But realize that there's a subtle difference between a web server as a file server and a file server that people are storing generic files on. Oftentimes people use cloud storage either for backup or to store large amounts of data that they don't necessarily want on their own systems. Because of this, the quantity of storage and the redundancy of storage may be more important of a factor than the low latency, high bandwidth. Realize that if somebody is storing their data on your cloud, they are trusting you to keep that data safe. A RAID 0 array would be the absolute wrong choice here. RAID 6 or some other level of RAID that guarantees that RAID volume from more than 2 drive failures is critical to providing the reliability necessary to store those types of sensitive files. We also want to maximize data storage in this case because most file storage services charge per gigabyte or per terabyte of space. Of course, we can't neglect the network interface or the throughput from that storage medium to the internet. Users are going to expect to be able to upload and download files at high speeds. Now, depending on the number of users for a given server, a 1 gigabit per second Ethernet port may be sufficient. But as the number of users increases, 10 gigabit or 40 gigabit Ethernet will be very important to keep up with the demand. Alright, let's transition away from file servers and web servers into application servers. So take another moment and think through some applications that could be virtualized or hosted in the cloud and think about what the most important hardware aspect would be. Do you have your answer? If you thought of something along the lines of CPU and memory this time, you'd be correct. Memory is going to be the most important aspect of virtualizing applications, unless it's a graphics-specific application, in which case we're going to need to look at adding graphical resources to the server, which is something we haven't really talked about much. But all applications will be running off memory. Now, while having large amounts of CPUs can be important to make sure that we have enough processing power for all of these applications to be running, the amount and speed of system memory is going to be the biggest bottleneck. Remember that if applications use up available memory, the system will start to swap files out of memory and onto hard drives, which will cripple the performance of that system. So we need to maximize our amount of memory to make sure that none of that drive swapping ever happens. While RAM is our primary consideration, CPUs is our secondary. Now again, depending on the type of application, if the application is disk intensive or if it relies on asset files that are stored on persistent storage, we'll also want to consider upgrading or increasing the speed and lowering the latency of our storage network, possibly with a good RAID card. While we're on the topic of application servers, let's consider the specialized use case of a game server. What hardware resources are going to be the most important for a game server? Take a moment and think about that. Do you have your answer? If you said graphics resources, you're thinking about desktop games. Realize that there's a big difference between gaming on a desktop and a game server that's coordinating a multiplayer environment or hosting the map that a user is exploring. The vast majority of graphical rendering actually happens on the client side, on the desktop, and that's where the heavier, beefier GPU is going to be. The server is only responsible for coordinating data or keeping track of large data files, and therefore system memory and CPU is going to be more important than graphical resources. Now there are some games that do graphics rendering on the server side. In fact, it's becoming somewhat popular to create pseudo-virtual machines or game streaming services to allow you to play games using cloud resources on a local device that would not have the resources to play a game. Google Stadia is a recent development in this particular area. But by and large, game servers really don't do a lot of graphics processing. The most important aspect of a game server is actually the networking latency, making sure that there's enough bandwidth and the lowest possible latency or the lowest possible transmission time between the internet and that particular server. System memory and CPU will be secondary considerations for a game server. Next, let's consider cloud security devices. Take a moment and think about what aspect of a server is going to be most critical for cloud security systems. Do you have your answer? If you said the CPU, you'd be right. Consider that most of these cloud security applications require processing and comparing data to a set of signatures or a set of firewall rules or making decisions on where to send traffic. In any event, this server is going to have to process and compare a lot of information, and the CPUs are going to be responsible for that. Now, if the software can take advantage of multi-core processors, then maximizing our threads is going to maximize our throughput. Of course, networking here is also going to be a consideration. While most companies today don't have access to a 1 gigabit per second internet connection, the number of companies that do is growing steadily. And there are even companies that have access to 10 gigabit per second internet connections. If we want to offer cloud security services to those types of companies, we need to make sure that our infrastructure can meet or exceed the bandwidth of their internet connection so that we can process their data either through a firewall, a proxy, or a load balancer and keep up with the transmission rate that they're expecting. So as you consider the services that you plan to use in your project, think through the specific hardware requirements. Then use the provided list of available hardware and prices to design the server that would best meet the needs of that service. Now, you may discover that you can combine services on a single server. For example, you can create a server that has extremely high performance disks specifically for web servers. But you also then have an excess of CPU cores and memory. And so you want to host a game server on that same physical device. That may be a more efficient way to offer your services on less hardware. But I'll let you come up with the creative ways of getting the best bang for your buck. After hardware, the next thing that we need to start thinking about is software. Consider a server that's going to be hosting virtual machines. What operating system or software are you going to need in order to offer that service to your customers? Take a moment to think about it. If you're thinking about a Type 1 hypervisor, you'd be correct. Obviously, if we want to offer virtualization services, we want to reduce the load on that equipment from our side so that we can maximize the performance that we're giving to our customers. And the most efficient operating system for hosting virtual machines is a Type 1 hypervisor. Now consider file servers or web servers. What types of operating systems can we use or should we use for those types of services? Take a moment and think about it. Do you have your answer? Realize that both Windows and Linux can host websites and create shared folders. However, while Windows has worked to improve IIS and has made some significant strides forward in making it more secure, the Apache web server is considered more secure and safer to use than the Windows IIS. Therefore, if you're planning to host websites, your users will be more familiar and more comfortable with a Linux-based system than they will be with Windows. However, when it comes to file servers in general, you'll have to consider who your clientele is and what type of data they plan on storing or how they plan on accessing and connecting to it. What about application and game servers? What operating system should we use for those? This one again is going to be tricky, and it's going to be case by case. Most video games that are multiplayer and online tend to run on Windows, so it makes sense that these server components are also designed to run on Windows. However, many games today also have the ability to host a game server on a Linux distribution. And due to the cost difference between a Windows operating system and a Linux operating system, it may make more sense to try and put those game servers on a Linux system. However, if there's not an option to run that game server on a Linux system, then a Windows system is appropriate. What about cloud security? What operating system should we use for cloud security services? I hope it didn't take you too long to think about Linux instead of Windows. Throughout this course, you've been working with pfSense firewalls, and pfSense is really just a stripped-down version of the FreeBSD Linux distribution specifically designed to work as a firewall router. And there are many other products that are similar stripped-down versions of Linux specifically for network security applications. And so it's a natural progression to use those types of operating systems based on the Linux kernel for cloud-based security applications as well. Now I realize the next couple of topics you may not have covered yet in the class, and so you may want to refer back to this part of the video after we've covered that content. But I want you to start thinking about the ideas of security and disaster recovery as it relates to these particular services that we want to offer. Let's start with security. As we consider the different services that we want to offer, let's think about the vulnerabilities and threats that each of those services are going to face, and what types of security measures we may need to put in place in order to protect those services. Web services is a great place to start. Realize that websites are oftentimes the target of a malicious individual either trying to gather information about a company or to harm that company directly. Therefore, making sure that that website stays up and is only editable by authorized individuals is important. If we host a website on its own virtual machine, for example, the access to that virtual machine should be severely locked down so that only ports 80 and 443 are accessible from the outside world. Realize that if a malicious attacker is able to determine the IP address of a web server, which is rather easy, and that web server has other open ports available on the public network, such as SSH, that server is significantly more vulnerable to attack than a server that is well protected by having no other ports on the public network. Think through some of the other services that we've talked about. What types of security might we need to add? Or how can we protect those services from the threats that they're going to face? Lastly, let's consider disaster recovery. If we're building a data center and our sole income is going to be from the services that we're providing to our customers, and the customers are only going to pay us for the services that they can use and access, we need to guarantee 24/7, 365 uptime in order to maximize our potential profit from that particular data center. Any interruption in service is going to result in lost revenue, either because we can't charge customers for the usage of our hardware or because our customers will leave and find another platform to run their application on. So maintaining uptime is critical. But in the worst case scenario, where no matter what we do, we can't guarantee that uptime, we need to have plans in place to recover services as quickly as possible. So consider the things that are going to go wrong. Power outages, loss of internet, hardware failure, fire, theft, or physical damage if someone breaks into our facility. What things can we put in place before those events occur in order to minimize the impact of those events? Or what things can we put in place ahead of time in order to help prepare us to recover from those eventualities? Then consider what it would take after the fact. If we have the right preventative measures in place, how long will it take and what would it take to restore full functionality? I hope this video has gotten you thinking a little bit more about what this project involves, and hopefully it's made you feel a little bit more comfortable about some of the topics so that it's not as much of a big, scary black hole. Let me know if you have any questions, and as you start working on the drafts of your project, refer back to this video if you have questions on specific areas. I may have covered your question, but if I haven't, please feel free to get in touch with me with your specific questions about the services and what it would take to actually implement them in a data center environment.